Hello, in this video, we're going to discuss how we actually publish LiDARs and camera data from the virtual world that are implemented in Unity to ROS2 that is installed in the Linux box, which is WSL2 in this case. And I'm going to show you how further those published sensor data are processed by perception algorithms. All right, let's get started. All right, so here in this virtual world, I have a transparent drone. Okay, under the transparent drone, I have attached generic lidar and a camera. Okay, camera is facing slightly downwards. It's about 20-degree downwards, and whatever the camera sees is shown on the left bottom here. Okay, now if I click on start, it's going to start to publish all these sensor signals such as lidar and camera. But before we do that, we need to do a little bit of a prep from the Linux side. So first thing is we're going to have to start receiving the published messages from the Unity. Okay, get it ready to receive published messages. So those are to do so, we're going to have to run this command, which should be familiar with you if you have followed the tutorials of the Unity ROS integration. Okay, so I'm going to start this. Now, since WSL2 only provides you with this terminal, you can't really start any graphical user interface for it. For us to do it, we're going to have to install third-party software, which I provide the link from the previous video. That once you install that X server or X launcher, you're going to have that on your machine. Let's say X launcher. Okay, you start this application and then click on next. Here you click on the second window, next. Third window, uncheck native OpenGL, check disable access control. Okay, click next, click finish. Then you're gonna see X window icon at the bottom. Okay, this software allows you to start a graphical user interface from the ROS2, from the Linux box. Okay, so here, open another terminal. Let's type in rviz2. All right. So this is the application that we are starting from our Linux box. All right. So here, from here, I can display the images that are published from the Unity. And then I can display the point clouds data from the Unity. Okay. So if I start, if I click on play button, you will see over here adding the topic. So first, let's see the image. All right. So on the left bottom, you're gonna see these images that are published from the Unity. Okay, from the drone camera, and then let me display the point clouds data also. All right. So here, so if I go down points. All right. So on the left, you'll see the point clouds that are received from the Unity, and displayed in the Linux box through the ROS. Okay, as you can see, as we move forward, point clouds are moving backwards. Okay, and this is the image that we see. All right, so this opens up the possibility. Now you can implement the perception algorithms on the Linux side, and then packaging it as a node, you can process this data and generates the processed information through the perception algorithm. All right, let's do that. We're gonna stop this. Okay, and I'm going to, for now, I'm going to for this demo of processing the sensor data using perception algorithm, I'm going to use the image data from the camera. Okay, so I'm going to turn off the drone, and I'm going to place some nice characters here, and I'm going to have them walk around and put a camera in front of it, and we're going to publish this camera image to the ROS, and then ROS will process those and generates the object detection. Okay, so on the ROS side, okay, once you go through all the tutorials that I described in the previous video, you should be able to understand what these directories are and what these files do. Okay, basically package all these AI algorithms as a ROS node, and these node subscribe the messages that are coming from the Unity and process it and generates the output as the printing the result on the terminal. Okay, and I'll make these codes available on the GitHub. Okay, so currently I'm using Detectron, generative, one of those generative AIs, and YOLO. All right, and the all these AI algorithms I downloaded from the Hugging Face. Okay, all right, and on top of that, I forgot to mention that the in the previous video, not previous video, in the drone, here you have a lidar and the camera. In the lidar, I modified the generic lidar renderer code so that it publishes the information. And also on the camera, I attached the script for publishing the images, and I'll make those scripts available in the GitHub. All right, so that's how you publish images and stuff. Let's get back to here. Okay, so if when I press start, these random characters will walk around, and it'll generate the images, and the images will be available on the RVids. Okay, so let me remove these things first. Point clouds remove. Okay, and you're gonna see the image on at the bottom, and when I start the AI algorithms here, you will see the object detection result on the Linux side. Okay, let's get started. So start, and those people will walk around and add image. All right, so as you can see, the camera follows these characters, and it's been published on the ROS side. So ROS2 run my, and then when you run this, now it'll start the AI side of it. All right, as you can see, it shows it detects people with confidence over 90%. So if I pause, the picture is paused. As you can see, with confidence 90%, it detected 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 7 people on the street. Okay, and it shows you the location, the bounding box location in this image with it. Okay, so this is the detectron, Facebook detectron algorithm implemented in the ROS node as a ROS node, and then I'm running it on the image that I'm receiving from the Unity. Okay, so this is the simple example of how you actually publish the sensor data from the, okay, so let's keep publishing from the Unity, and how to process it on the Linux side. All right, let me show you another example. Okay, so let's stop this, and this time I'm going to use generative AI. So here, let me stop this. Okay, so here, instead of people walking, now I'm going to use some dancing animation. Turn this thing off, audio on. All right, so here, if I start, when I start, it'll or these people will start to dance according to music, and then on the Linux side, I'm going to run a generative AI and see what the generative AI talks about the people who are dancing, what it thinks about dancing people. Okay, let me see. So generative AI, I call that generator. Okay, so generator. All right, let's get started. Oh, okay. So those people are dancing. Let's see what the generative AI thinks about this scene. All right. So these are the outputs from the generative AI. It thinks people are riding on the back of motorcycle, skateboard, things like that. Okay. So this is just an example of how you actually publish the information from the Unity and process it through the perception algorithm implemented as a node in ROS. All right. So this opens up huge possibility of the research. Okay, you can implement however the world looks like from your side, and then you place sensors and you process those sensors using AI algorithms. All right. Okay, so that's it for this video. Thank you so much.